This is Paul Verschoor with Victor Lamme. And Victor was just telling us about his theory on consciousness, in particular setting up a contrast between his approach and what's also called global workspace. And in some sense, the starting point for you was very much the statement like, well, a correlation-based approach towards consciousness is just not going to get us there. It's not enough.
Yeah.
So what's the problem with correlation?
Well, the problem with correlation is that you have to start out with a definition, in this case of consciousness, of which you're sure of, and then you can try to find out what that means on the neural side. But of course, the real problem with consciousness is that we don't really know on the psychological or introspective side what it really is. We don't know what we are conscious of. We don't know what consciousness really is. We don't know what it's used for. We have actually no clue of what consciousness really is on the introspective, psychological, behavioral side. So then, of course, it also doesn't make any sense to just try and find a neural code of that.
So you mean, as long as we have no satisfying definition, we don't know what we're correlating it with?
Yeah, that's the basic problem. So my stance would be to build a definition using neuroscience. So to incorporate neuroscientific findings and neuroscientific theories inside, neuroscientific arguments, you might even say, into building, what you might call a new definition of consciousness, which, of course, to some extent incorporates the old ideas we have about consciousness from introspection and psychology, but to some extent also overrules or overrides those intuitions by things we find out from neuroscience.
But isn't there a risk that this becomes circular? Because you're saying, okay, we don't have a satisfying definition right now. So let's try to develop one looking in more detail at neuroscience, but it would imply that you have to have at least an intuition which subset of phenomena you want to look at in order to develop this definition. So what's that guideline now that helps you to identify these phenomena?
Yeah, the intuitions to some extent are fine. So, for example, it's not problematic to have the intuition that, say, in deep sleep or in coma or when you have a fully masked visual stimulus, that in those situations you do not have conscious sensations. So that's an intuition which works fine. And also at the other extreme end, when you have, a visual stimulus being presented and someone says, yes, I see this visual stimulus and I recognize who was in that picture, etc., etc. There's also no real reason to doubt that in that case people have conscious sensations. But it's particularly in the middle ground where you go from these clearly unconscious situations to these clearly conscious situations where we don't really know whether people are conscious. We don't even know whether we self have conscious experiences. And that's the situation where you have to extrapolate from these extremes towards these situations in the middle. But you can only do that properly if you take into account the neuroscience, which goes along with it.
All right. So you're saying there's like this gray zone that we have to disentangle, and that's where we have to include more constraints.
Constraints from, of course, also from psychology and introspection, but I think even more rigorously constraints from neuroscience. To give an example, if we see all the essential characteristics of neuroscientific processes which go along with situations where we clearly have a conscious percept, like when we report having a conscious percept, if we see all the key neural ingredients of that situations also happening in situations where we have doubts about whether we have conscious sensation, then we might conclude on the basis of that neuroscientific evidence alone that in those cases we probably have conscious sensations simply because the neural mechanisms are so similar in both situations, or at least are similar as long as with respect to the essential ingredients of consciousness, that we have to grant consciousness to situations which intuitively we might think we don't have conscious sensations, like in neglect or when we suffer from inattentional blindness or attentional blink. Typically in situations where attention is removed, there you have, this is in particular the situation where you have this gray zone of, well, that we don't really know whether we have conscious sensations or not.
Right. So given that, this might also explain why you use change blindness as one of your paradigms, or not.
Yeah. So we use change blindness to a large extent, showing that on the one hand, if you take the change blindness results per se, you have the inclination to think that consciousness is very limited only to what you attend to, that you only see a couple of objects at the same time, maybe 2 or 3 or 4. Whereas when you do the change blindness experiment in a different way, using the, let's say the iconic memory version of the experiment, where you present a cue in between the first image and the second image, you will see that there is at least evidence that people have a much richer representation somewhere inside their heads. The only thing is we don't really know whether that is a conscious representation. Now, and into trying to find out whether that rich representation is a conscious representation, you could use neuroscience to try and find out whether all the essential ingredients for consciousness that you do find in situations where consciousness is unequivocal, whether you also find those in the situation in this rich representation, iconic representation, and then conclude, well, apparently, even though it's uncertain behaviorally and introspectively whether there's consciousness there, we have sort of forced to conclude based on neuroscience that indeed people do have a conscious sensation there, and that as a result of that, we are forced to conclude that consciousness is not limited and only limited to what attention is focusing on, and limited in respect of that it only entails about it only holds a few objects, but that it's much richer, and that indeed you perceive a whole scene all at once.
Are you then not actually posing two questions? So on the one hand, it would be like, what's the content of memory, and then under what conditions and which aspects of memory are accessible to conscious experience?
Well, you do the experiments. In the way you do the experiments, you are there addressing memory. That's correct. But of course, what that tells you is what the content of consciousness is at the moment you look, because it's very difficult to really know what the content of consciousness is at the very now, at the moment that you look. So the only way to go about that is ask subjects, what they saw when you've presented the stimulus. And of course, essentially, that's always about memory. But what turns out to be the case is that you have different forms of memory of a particular visual scene that you see. So you have the working memory, which is limited to a couple of objects. And then you have iconic memory, which is much more widespread and contains many more objects. And these two sorts of memory are remnants of the two different representations that you had while you were viewing the scene. While you were viewing the scene, you probably also had a focused representation, focused attention being focused on a few objects, which you could cognitively manipulate and things like that. But at the same time, you also had a much richer representation containing many more objects, which you were not attending to and which you could not cognitively manipulate, and which is linked to this iconic memory trace. So the memory traces tell you something about the representation that exists at the moment that you look, which is, of course, the real question.
Then, but in the case of change blindness, there might be, let's say, at some level, that change blindness becomes almost trivial. I mean, there are, let's say, given that perception means that you have to compress, you have to throw away, if you want, signals to get to a percept. So in that process, of course, there will be, let's say, pieces of information and objects disappearing from memory, possibly, or from consciousness, because it's also a necessary ingredient of just being able to perceive the world at all. So from that perspective, you could argue, well, it's not a big surprise that it is a finite set, right? That both the iconic memory, but also then, let's say, your working memory for visual processing would be finite. So why then is it still why then can this paradigm give you an additional insight into this interaction between perception, attention, and consciousness?
Well, obviously, whenever you go from a physical stimulus falling on your retina to a representation in consciousness, there's some sort of compression going on and some sort of interpretation of this. You have things like visual illusions, which tell you that whatever is physically out there is not translated in a direct way into your conscious percepts. There's some things like memory and previous experience and all that thing going on. But regardless of that, what remains is that apparently in that transition from the physical stimulus to these mental representations, you have, well, so to say, different representations, different stages. You have a representation which is rich and detailed, which contains more or less the whole scene, albeit in a interpreted fashion. And then you have a representation which is related to the focus of attention, which is more limited. And you have these different representations all sitting there at the same time inside your mind. And the real unanswerable question, at least unanswerable from an introspective and behavioral point of view, is which of these representations is the conscious one. That's the real problem. And that's the thing which we cannot answer from introspection or behavior.
Right. So now there you, to answer now that question, you also are introducing a fairly specific picture on how visual perception would work, right? According to a number of stages. Mm-hmm. So what are these stages exactly? On the ground of what did you distinguish them?
Okay, so whenever a visual stimulus is presented to our eyes, basically we go through 4 stages of cortical processing. First you have let's say a fairly shallow processing, feed-forward processing by early visual areas and maybe a couple of more high-level visual areas. And then following that, if a stimulus is attended, you will have this feed-forward processing penetrating all the way up to higher visual areas, motor areas, prefrontal cortex, etc. So those are the first 2 stages which are sort of automatically executed. Feed-forward processing either in a shallow or in a more extensive, deep fashion, depending on attention. And then after that, you have what I call stages 3 and 4, where you have recurrent processing, which means higher level areas feeding back into lower areas and then engaging in reentrant or recurrent processing. And then also you can have these reentrant processes being either of a shallow nature in the sense that they only involve, for example, a few visual areas, or that they grow more widespread when attention is allocated to the stimuli that evoke these processes, where the reentrant interactions also include frontal parietal cortex, and you have, well, what others would typically call global workspace ignition, amplification, and things like that. Okay, so it's an incrementally more complex circuit we're looking at. Yeah, and exactly. Also bringing in more and more top-down information, or higher level cognitive information. Well, I wouldn't put it that way, because also already in the feed-forward activation, you can reach high-level areas like the prefrontal cortex, and we have done some experiments showing that when you have this feed-forward activation of prefrontal cortex, that may activate cognitive functions like inhibitory control or attention and things like that, which tells you that these feed-forward activations, which we think on the basis of all kinds of experiments are not generating any conscious sensations, that these feed-forward activations may still activate all sorts of cognitive functions like attention or cognitive control, but nevertheless are unconscious. And of course, similarly, you can have recurrent interactions which are either penetrating deeply or not, and that means that you would have conscious versions of either attention or cognitive control, meaning that in this view, consciousness and attention, or consciousness and cognitive control, or any other cognitive function, are essentially orthogonal, meaning that you can have both unconscious attention and conscious attention, that you can have both unconscious cognitive control and conscious cognitive control. But then in these 4
phases of processing? What's the minimal configuration that could give me a conscious percept?
Yeah, so I think the evidence points to the idea that the minimal configuration you need for having a conscious percept is that you need to have reentrant recurrent interactions. So stages 1 and 2, which are entirely feed forward, even though a stage 2 process may reach prefrontal areas, high level areas, that still will be an unconscious process in the sense that it's not accompanied by any conscious sensation. It's only when you go to stage 3 where you have reentrant interactions, or to stage 4 where you have widespread reentrant interactions, including frontal parietal network, that you have conscious sensations. That's the idea I'm pushing forward.
But this seems to be a more necessary condition for consciousness and not a sufficient one.
Yeah, this whole necessary versus sufficient argument is not getting us anywhere, in the sense that you could always say that something is either necessary or sufficient, or not necessary or not sufficient. What I'm trying to argue is that whenever you have reentrant interactions, you have a conscious sensation. The only thing is that when these reentrant interactions are limited to early visual areas, you will have a visual sensation, which is not linked to cognition, not linked to reportability. So you cannot report it to the outside world. You cannot store it in working memory, etc. But you would still have a conscious sensation. And of course, when these recurrent interactions grow more widespread to stage 4, to when they incorporate frontal parietal network, then you will have a conscious sensation which is also reportable, which you can cognitively manipulate, which you can attend to, etc.
Okay, so it means on the one extreme we can say, well, you don't necessarily need a pure frontal engagement to have a conscious experience. Right? This is one important consequence of what you're saying.
That's certainly one of the important consequences.
But that's the upper bound, if you want. But now at the lower bound, maybe things are a bit more fuzzy, because in some sense I could argue, well, already at the level of a primary visual area, I will have dense recurrent interactions locally to the area and with the thalamus and so on. So I have recurrence. However, if I would only stimulate V1, as also some studies have shown, I would not necessarily consciously experience that stimulus. So it seems that this recurrence of a minimal recurrence of a certain kind must be present to then lead to a conscious experience. So what's that minimal requirement on recurrence?
Yeah, there's probably some minimal requirement which we need to add to that, if you like, definition of consciousness. I'm not entirely sure what it should be. Maybe it has something to do with the amount of complexity of the interactions, or a la Tononi and people and proposals like that. But if you would ask me, basically, I would say that, whenever you have reentrant interactions between visual areas, you have some sort of visual percept. Of course, it might be a very primitive visual percept, like, only seeing a glimmering of light without any cognition added to it, without you really knowing what the object is, without you robbed from any normal sense of vision that you would normally have. But still, it would be a conscious percept, And the only thing that is added when these reentrant interactions incorporate more visual areas, let's say object selective areas or face selective areas or motion selective areas, what you add are more layers in terms of essentially how beautiful the visual sensation is. We see you add colors, you add motion, you add shape, you add whether it's a face or not, and stuff like that. So all this gets added to the visual percept, but that doesn't make it a more conscious visual percept. It only makes it a richer visual percept. But in every case, it's a conscious visual percept. The only thing is that when the recurrent interactions are very localized, it's a fairly poor and sorry visual percept, and in the other case, it's a rich and very beautiful one.
Okay. Now, in the data that you described, though, there was another aspect that came to the foreground, where you had these unconsciously perceived faces that you masked out. Remember, you had these And then you generate crosses from everything, but actually subconsciously a phase might have been detected. When you looked at that data, it looked like the main distinguishing factor was the whether there was sustained activity or not.
That's true.
So would you accept that as a second parameter where you could say, well, maybe to become a consciously perceived stimulus, I have to trigger sufficiently sustained activity to engage these recurrent circuits sufficiently, possibly even including frontal circuits, to construct the experience. Would you buy that?
Well, the short answer is no. Simply because, experimentally it's of course very difficult to tease apart sustained activity and reentered or recurrent activity, because you cannot have recurrent activity without it being sustained. Well, you might have sustained activity without it being recurrent, but at least the other way around, it's very difficult to tease those two apart. So you might argue, well, maybe it's just about the activity being sustained, which is generating the conscious percept. The only problem I have with that is that, it doesn't explain anything to me. Why would neural activity that is more sustained give you a conscious sensation, whereas activity that is less sustained would not give you a conscious? That doesn't make any sense to me. Well, on the other end, the difference between recurrent and feed-forward processing is so fundamental in the sense that recurrent activity will give you the integration of information over different areas of the brain. As I've proposed in the talk, it might also give you things like more synaptic plasticity being engaged. And, there are many fundamental differences between recurrent activity. It will give you higher complexity of the neural networks that are involved. But there are so many fundamental differences between recurrent activity and feed-forward activity that I find some explanation in that being the difference between conscious and unconscious processing, which I totally do not find in short versus sustained activity.
But imagine I would be a global workspace person. Yeah. And then in some sense, I would agree with you on recurrent connectivity. Because I would say, no, I have highly complex and differentiated and integrated global interactions in these networks. And then I could argue, and I need, at the input side of that, I need an activity of a certain duration to drive this global workspace sufficiently. So if I have one of these masking tasks, so the stimulus gets suppressed, I cannot drive the global workspace circuitry sufficiently. So therefore, conscious percept cannot emerge. While if I have a more sustained activity, I can drive the global workspace and develop the consciously experienced percept. But what would be wrong with that argument?
Well, of course, what you're saying now is that the conscious percept is not coming from the sustained activity itself, but from the sustained activity driving something else, in this case, global workspace activation. So essentially what you're saying is that the conscious sensation comes from the global workspace activation.
But that a necessary requirement of that is sustained activity.
Well, what I've tried to point out in the presentation is that, of course you could hold the case that you only have conscious sensation whenever there's global workspace activity, but there are a number of theoretical, scientific, and other problems with that, such as that, this entails that for some reason it's prefrontal cortex activity which is important for consciousness, which doesn't seem to have any explanatory power. There's of course lots of evidence that you can have prefrontal cortex activation without you having any conscious sensation. So again, there's no real reason to assume that you need to have prefrontal cortex activation for generating consciousness, or rather the other way around. You can have prefrontal cortex activation without you clearly having any conscious sensation. When you assume the global workspace activation to be essential for consciousness, you always conflate consciousness with attention. You conflate consciousness with cognitive control. And also you're not capable of dissociating consciousness from a report about consciousness. So there are lots of reasons why saying that global workspace activation is the essential thing that you need for having a conscious sensation from a scientific point of view seems, misguided.
So that's an important part of your story, where you're saying, well, global workspace is one view on conscious experience, and I disagree with this view for a number of reasons that you now just summarized.
Yeah.
And my alternative proposal is the one of recurrent interaction of some kind. So, but to what extent is your proposal not also consistent with a possible alternative interpretation of a global workspace? Because I could argue, well, these systems you point your finger to are like still global workspaces, but at a smaller scale.
Yeah.
Not necessarily inconsistent.
Yeah. Okay. But of course, if I discuss this with the real proponents of global workspace theory, they explicitly excluded the possibility of global workspaces being possible at a more local scale. Because indeed, you're right. If you would acknowledge that you can have global workspace on a more local scale, let's say only visual cortex, then of course it's totally similar to what I'm saying. But for some reason, which by the way is totally a total mystery to me, a central tenet of global workspace theory, as it has been put forward in the last couple of years, is that it requires the global broadcasting of information via these frontal parietal network throughout the whole brain, which is essentially different.
But that seems to be the sticky point, right? That seems much more a debate on whether this frontal parietal network is a necessary ingredient of consciousness and sufficient even, or not. Yeah, because if you would leave out this component, you could happily agree on some sort of adapted version of what you might call a workspace.
Sure. Mm-hmm. I wouldn't see any reason for calling it a workspace, though. But but scientists more easily use each other's toothbrush than each other's terms. So, but aside from that, why not?
Okay.
Yeah, that's
so. From now, you talk about the visual workspace. Okay. But then the other thing, before getting to the conclusions here, what I found very interesting is that you also really started to push this notion of feed forward and recurrent down to the neural substrate, to the level of actually receptor types and so on.
Yeah.
So can you maybe explain that a little bit?
Yeah. So let's say from a theoretical point of view, we had let's say hunch that there might be differences in the molecular machinery that is used for feed-forward processing as opposed to recurrent processing, and in particular that recurrent processing, because it satisfies the Hebb rule and stuff like that, would be more prone to induce processes related to synaptic plasticity, NMDA receptor activation, and stuff like that. So we did some experiments, to sort of verify this hunch, and indeed we found that in monkey visual cortex, the recurrent signals are, almost abolished when you apply NMDA receptor blockers like APV, while the feed-forward signal is not. And conversely, you can block the feed-forward signal by an AMPA receptor blocker like CNQX, which doesn't interfere that much with the recurrent signals. So indeed, pointing out that there might be different synaptic mechanisms related to feed-forward and recurrent processing. And that triggered the idea that maybe recurrent processing is much more related to inducing synaptic plasticity, learning, in other words, changing your brain. And then, of course, ultimately this could imply that the difference between conscious and unconscious processing is that conscious processing changes your brain because it induces synaptic plasticity, whereas unconscious processing does not change your brain, which, at least to me, gives sort of a fundamental hunch or intuition about what consciousness is really about and what the real difference is between conscious and unconscious processing.
But would you be willing to really say, like, well, a necessary condition for learning in the brain is consciousness?
Yeah. So let's say a funny prediction of that idea would be that there's no such thing as unconscious learning, which
is already contradicted by the existing literature.
Well, actually, if you look at it closely, it's not, because all the instances of unconscious learning that I've come across are mostly about what I would call inattentional learning, which is something else entirely. So all the instances where you find so-called unconscious learning are in fact instances where you might, well, you can fairly well assume that you still have these reentrant processes going on a local scale, although not at a global scale, so that indeed people are not able to report about these stimuli that evoke the learning. But for example, unconscious learning has never, in my mind at least, been convincingly shown in cases where you can really be sure that there is no recurrent processing going on. Like, for example, when you have a fully masked visual stimulus, which is only evoked feed-forward processing, you will never find any learning related to such a fully masked stimulus. It's only in cases where you rather manipulate attentional reportability where you find.
And how about motor learning?
So-called unconscious learning.
How about motor learning, like in conditioning or forms of learning dependent on the cerebellum?
I'm not an expert on that, so I'm going to take the fifth.
They exist. They exist. I'm telling you.
The cerebellum. That was already pointed out, of course, in various talks. The cerebellum is a very strange system in the sense that even though you might have recurrence there, there's still no. It's probably not associated with conscious experiences, and it's. I have nothing to say about the cerebellum.
Okay, yeah, it's too scary, Yeah. So now look to conclude, I have two questions for you. So on the one hand, you went on this trajectory actually being more very closely to the data physiologists, gathering data in monkey and other animals. And now you're moving more to these really challenging questions in the domain of consciousness. And given that experience, what's the Victor Lamme law you think we should all adhere to in our study of the brain and consciousness?
Well, I think there are two laws. The first law is that you cannot know what either someone else or yourself is conscious of at any particular moment in time. You simply don't know what the content of consciousness is. And of course, the upshot of that is that it's useless trying to find neural correlates of consciousness. I would say the second law is sort of following from that, of course, that we don't need neural correlates, but we need neural arguments to tell us what consciousness really is. And if I put all the neural arguments together, of course, with psychological insights and introspective insights, I have the strong idea that the fundamental ingredient for consciousness is recurrence.
So now, if 5 years from now I go up to Amsterdam and I'm going to find you and chase you down and ask you like, okay, Victor, 5 years back you made this prediction. I'm going to check with you whether it was right or wrong. So what's this one prediction you were willing to stick your neck out for today?
Oh, well, one of the predictions would be like the things we discussed about learning. This is something I really like very much because, the link between reentrant connections and NMDA receptor activation, that's really putting some sort of fundamental ground under this whole idea of what consciousness is about. So, I think at that point we will have proven that there's no such thing as really unconscious learning, and that you, for example, that you only get, say, visual learning from inattention paradigms and not from not from masking paradigms, for example.
Wonderful. Victor Lamme, thank you very much for this interview.
Well, you're welcome.